What do you know about percentages? Tell me something. What were you saying? Multiplying by 100. Very good. What else do you know? Yes. Very good. What else do you know? Why 100? Yeah. Good. Tariq, you had your hand up. That's what a percentage is it's a number out of 100. Okay? Don't write this down, just watch. We talk about like scales and that kind of thing. Okay? So if I make a percentage scale where 0 is here and 100 is here, then, there's half. If I'm at less than half, I'm down here. More than half, I'm up here. Right? Like, it's out of 100, but we think about it in terms of a scale. So if it's a test out of 75, then this is percentage. This would be 75. What would a half be? It's 50%, but what is it out of 75? It's a hard one because dividing that by 2, you're going to get decimals, right? What would a quarter be? What would failing be? What would passing be? What would be a good mark? What would not be a good mark? That's going to be different for different people, right? But that's what a percentage is. What if you write 2 tests, one of them's out of 75 and one of them's out of 120? How do you know which one you did better at? That's like when you're comparing fractions with different denominators, it's hard to compare which one's bigger. Didn't we talk about this for like the better buy yesterday that we did? Which one's a better buy? It was hard to tell because they weren't in the same, they weren't for the same amount. $3 for 250 grams or $4 for 315 grams. Which one's better? Hard to do when the numbers are close. So a percentage is another way that you can easily compare different values. It's called a standard because it's always out of 100. That's what a percentage is. So somebody already told us this. Decimals, fractions, and percentages can all be considered different ways of talking about the same thing. Okay? Depends on what you're talking about, but they often mean the same. We're not really going to talk about fractions today. We're going to look at the relationship between decimals and percentages and then apply them. Okay? So eventually, it's a good idea if you can convert between all of them, or if you at least understand the idea that a half as a percentage is what? What do you think, Caleb? A half as a percentage is what? Cole, what do you think? 50%. Does that make sense? What about a quarter? 1 over 4. What's your gut tell you? 25%. Got it. So you could do it, right? So we have some understanding, some gut feeling about some of this stuff. But we're not going to deal with fractions today. Sure can. 50%. And this is like a half. 0.5 is like a half, but don't worry about that. How do I solve it? So this is like 0.5 times 100%, which is 50%. When you're answering these questions in math class, it is important to use the percentage symbol. Otherwise, your answer would look like this. 0.5 equals 50. That's not true. 0.5 is a number on a number scale that's really small, and 50 is a number scale that's very big. This is like a child is half a year old, 6 months old. An adult is 50 years old. Half a year and 50 years is not the same thing. Damien, do you agree with that? Yeah? Yeah. Half a year old and 50% of a year old is the same thing. That's a weird way to think about it, but that is the same thing. So if I add a percentage symbol, they do mean the same thing. So if you forget it, I'll probably just remind you for now. But again, that's kind of why units are important. Okay, try the next one. You might have a gut feeling about a lot of these, and that's great. And the more you can do in your head, the better. You also want a strategy for how to calculate if it's one that doesn't make sense or is hard. Ravanja, you answered the last one. Somebody else. Noah, what do you think? Do you know how to convert 0.15 to a percentage? Did you do it already? I thought I saw you doing some of them. So what did you do?
So I did 0.15
And what did you get?
15.
So 0.15 is 15%. Nice. And the strategy was that Noah told us, multiply by 100. It's so easy. Take a decimal, multiply by 100. For every decimal, that will always work. Well done.
So, for 15, is 0.15, not going to a fraction,
You don't have to, no. Does it say to do that? Convert each decimal to a percent. If you can, that's great, but don't worry about it. As you're working on this, if you like the idea of kind of doing it in your head or thinking about it, always think about 2 decimal places. So this one has 2 decimal places, they're 50, so it's 50. This one has 2 decimal places, right? But the 0 wasn't there before. Are you watching? Everybody watch. You're all trying to get the work done, I know, but I want you to think about this. If I add a 0, so we have 2 decimal places, now I see 50. This one I already see 15. What's the 2 decimal places here? They're both zeros. So when I do this one, it's going to be a small percentage. What does it work out to? Lauren, do you know this one? Do you have a calculator? Can you do 0? This is hard. Don't try not, like, sometimes these ones that are strange ones, you don't want to do in your head. So 0.003 times 100. Lauren's doing it for us. 0.3%. So some people might have said, if you were kind of guessing, 3%. But it's not 3% because those are both zeros. So it ends up being 0.3%. Just like this one. It's similar, right? Where are my 2 decimal places? But there's other numbers. So what's going to happen when I solve this one? Liam, did you do this one already? What did you get? What did you do? Yeah. Very nice. 134%. Can anybody tell me what that means? What, how can you be more than 100%? What were you going to say? Okay, that's fine. Yeah, Liam. Yeah. I ate 134% of a pizza. I ate more than one pizza. Or if you got 134% on a test, you got like bonus marks because you did better than perfect, right? Or sometimes it might be something like 134% the size. So you've got like a can of tomatoes and they increase the size of the can. I don't know. You can see it. You see athletes talking about giving 130%. That's not actually possible, right? But it's just a saying, like, where's my 2 decimal places? 0.0. I know a lot of you have done this, so I'm just going to kind of whip through them here. So this works out to 5%. That's what like just 5%, 6%, 7% would look like it's decimal. And what's 1? Ty, what do you think? 1 is 1. So what you think is 1%? How would I show it mathematically? What's the strategy we use for all the other ones? 1. So what is it? Nice. So 1 as a number means 100% as a percentage. And then going the other way, how do I, somebody remind me how I do it? We'll just do a couple of these. You do some division, very good. Emma, what do you think? What's too hot? How do you convert a percentage to a decimal? So 12 divided by 100. One direction you multiply by 100. The other direction you divide by 100. Right? If you know how to go one way, you can figure out how to go the other way. And this gives me 0.12. It's great to know the answer, but it's better to have a strategy to calculate the answer in any situation. 12% might be easy. 40% might be one you just know. What's 40%? But what about 0.3%? Or what about 107%? Or what about 200%? Some of those stranger ones can be harder. So what's our strategy? Divide by 100. This is going to work out to 1.07. What's 200 divided by 100? 2. So 200% is like 2. This is really useful because when we use percentages, we turn them into decimals first. So you're actually going to do more of this than the other thing, typically. Okay? Any questions before we get started? A little tip. So this is on the back of your page. Don't worry about the other ones. You can do them if you want, but we skipped a few there. That's okay. Using percentages. A little tip. The word of, when we're talking math, almost always, maybe always, but almost always means multiply. So 40% of 80 means 40% times 80. But it's not 40 times 80, because 40 and 40% are not the same. Ethan, what do you think? Right. So there's a couple of ways I could do this. I could do 40% equals, actually I'll do it this way, equals 40 divided by 100, which equals 0. We already did this one, remember, it's 0.4. So 40% of 80 is 0.4 times 80. Get out your calculator. And what is it? Aaliyah, did you do it? Oh, 32. Who got it? 32. Thank you. If you want to do it in one line altogether, like I did it in sort of two little steps there, but I could also do, so it's 0. See, this looks like a decimal, so it fools us. This is one of the tricks that our brain plays on us sometimes. It's already a decimal. But don't write this down. What is 0.3 as a percentage? It's 30%. This is 0.3%. Not the same thing. Just because it's written as a decimal doesn't mean it's like the decimal we use. So this is 0.3 divided by 100 times 350. Right? I can do it in one step. Try that on your calculator. You know what? Give it a try. Really? You have an answer for it? It's on the back. It's on the back. No, the back of that, though. We're working on those questions now. What is it? 1.05. Anybody else get that? 1.05? Was it exact or was that rounded? Do you remember? Exact? Nice. Good. Good. Everybody okay with that? Okay, try this one on your own. Can anybody tell me what this looks like? What this question looks like? Caleb? Taxes. How many people know that 13% is the sales tax in Ontario? Right? So you got a little box there that tells you a bit about it, but 13% is sales tax. So if you're calculating tax, this is how you would do it, right? But stores always do it for us. Now imagine, like, it's not even that long ago where they didn't really have computers. Like, computers were only invented not very long ago, right? Now, calculators existed before that, different kinds of calculators, but computers themselves are a new thing. So in stores, how would they find tax? They'd have to be calculating it by hand, right? Not that long ago. So this is 13 over 100 times 64.99, which is what? 8.45. You rounded up to 45. Very nice. So you'd pay $8.45 in tax on something that costs about $65. What costs $65? A video game these days costs $65, maybe a shirt, pair of pants, something like that. You pay almost $10 tax. Every province is different. Every state in the States is different. Countries in Europe are all different. So tax is not a universal thing. Ontario happens to be 13%. What's that? Where? Yeah. There are some states that have no sales tax. But sometimes you get busted when you're bringing it back over the border. You have to pay tax when you cross the border or something like that, right? And in Ontario, almost everything is just HST, but there are a few things that you only pay GST or only pay PST on, but only a couple of things are left that are like that. And there are a few things that you don't pay tax on. Do you know what kinds of things you don't pay tax on? Say again? Bakery? Yes. Food. Groceries, that kind of stuff. Junk food, yes, you often do, but groceries, you often don't. What were you going to say? Okay, so GST is a general sales tax. That's like a Canadian thing. PST is provincial. So Ontario's, we've had an 8% provincial tax for a while, but GST went from 7 to 6 to 5 over the last 20 years. And then HST is harmonized. So Ontario, a few years ago, instead of being at like PST and GST, they just said, you know what, we're just going to lump them together because it makes it simpler. So now it's called a harmonized sales tax. We don't really think about it in terms of GST separate from PST anymore. We just pay 13% on everything. But like I said, there are a couple of things like cars or something like that where you pay one and not the other. There's a couple of things that are still like that. For math, if you're asked for tax, it's 13%. You don't have to know what you pay tax on and what you don't at all. Okay? But it might say, what's 5% of something? And it might mean tax or it might not. You know what I mean? Like, you have to find every percentage. But if it says tax, 13%. So here you go. Here's a question. A shirt costs $34.95. How much tax will you pay if you buy the shirt? Go. Try it. And how would you show your work if it was important on a test to show your work? Think about how you would show it as well. Did you do that in your head too? Just 0.13? You just know that? Tariq realized that 13% is 0.13. We've already figured that out. But we've already done that. So if tax comes up over and over and over again, and you already know that 13% is 0.13, that's easy to just jump there, right? Okay, so people did different things, but this is one way that you could do it. So it's 13 over 100 times the price, and you should get something like 13 divided by 100 times 34.95. You should get something like $4.54. How many people got that or something like that? But a few of you got something different, so I want to show you why. Okay, so then how much therefore we will pay. I'm going to skip that part right now, but if it was a test, you'd want to say this, right? How much will the shirt cost in total? Somebody explain how we would find this. Damien, what do you think? Add them together. Very good. Total cost equals the original cost plus tax. So $34.95 plus $4.54. And that works out to, say it again, $39.49. Therefore, the total cost is $39.49. That feels about right. About $5 more in tax. Feels about right to me. Some of you got 39 as your first answer. So you did it a different way, but you need to know that $39 is not what you pay in tax. That's a total cost. That's different, right? Okay, one more. On the second page, you should have one more. A laptop costs $599 at the regular price, but today only. There's a back-to-school special. You need to show your student ID, and you get 20% off. What's that? You do sometimes. Students get discounts on things. Teachers get discounts on things. Yep. Sometimes. Usually before the school year starts. Or at the very beginning of September kind of thing. What is the amount of the discount for students? How are you going to find this? 20% of $5.99. Okay, good. So what Ethan told us is you take $5.99 and you multiply by 0.2 or 20 over 100. Very nice. What'd that give you? Go ahead. 119.8. That is a good discount. You just saved $120. 20% is a good discount. Vivanja. What about tax? Nope. We just want to know the amount of discount. So now how do I find the cost after the discount? Who can explain that? Alana, what would you do? So if it costs $5.99, but it's discounted $119.80, what would you do? What's your guess? What's your gut tell you? Not sure? What do you think, Em? Yeah, subtract the amount that you're going to save. You think that makes sense? Okay, so let's do that. $5.99 minus $119.80. So I got $479.20. What will be the final cost with taxes? So now you can go and calculate tax. I'm going to leave that up to you. I'm going to leave that for a minute and let you try to get an answer there. Then we'll take it up together. Yeah. Here's the practice page coming around, okay? Front and back. Every bit of practice is worthwhile to do. So it's always a case that like the more you practice, the easier everything is going to be, the easier the tests are going to be, the easier tomorrow's lesson is going to be or tomorrow's activity. The more practice you do, the better, as long as it's good practice. So if you're practicing properly, it's always going to help. Hopefully you got this part. So taxes. How many people got 6230 as their answer? So my calculator said this. And 29 rounds up to 30. Right? Because the 9 rounds up, so the 2 goes up as well. It's like a 29 that rounds up to 30. That's the idea there. That's a hard rounding. But because of the 6, the 9 goes up. So then what I do is I actually look at 2 decimal places and I think, well, the 29 rounds up to a 30, the next bigger number. Do you have a question or are you giving me the next answer? Say again? Give me the next answer. So total cost, $534. Okay, so I'm going to show this. Is going to be the $479.20 plus tax, and it's $534.50. Very nice. Therefore, the total cost or the final cost after discount and taxes how's that? Any questions?